In this video, we're going to do a brief background on the metric system and then do a few examples. One way you can remember the metric system is by memorizing this saying: Mean King Henry died unexpectedly drinking chocolate milk on Monday. If you notice, the first letter in each word of that saying corresponds to the prefixes that would be in the metric system. Mean King Henry died unexpectedly drinking chocolate milk on Monday. If you write that out, you'll have a basic idea of what the metric prefixes are. Mega, kilo, hecta, deca. The U stands for whatever unit you're looking at, whether it's gram, second, liter, or meter. And then deci, centi, milli, and micro. Below, you'll actually see how that prefix would be written out in unit form. Now, a couple things. First of all, we're missing some prefixes. There's more prefixes than just this, but the saying would be really long if we included every prefix. But there are a few extras that you'll need to be aware of, and so let's write those in. After micro comes nano, and then after nano comes pico. If you go the other direction, after mega would be giga, and after giga would be tera. Now, in chemistry, we typically don't deal with large amounts, and so we're going to probably not be over here too much. We're going to be staying in this general region in chemistry because chemistry deals with smaller things. The nice thing about the metric system is it is based on a power of 10. So if you imagine the unit is where you're starting, or in other words, the unit would be the number 1, deca is going to be 10 times the size of a unit. Hecta is going to be 100 times the size of a unit. Kilo is going to be 1,000 times size of the unit, and so on and so forth. If you go in the other direction, deci is 1/10 the size of a unit. Centi is 1/100th the size of a unit. The milli is 1,000th the size of a unit, and so on and so forth. These can also be written in scientific notation. The unit would be 10 to the 0, and then it would be 10 to the 1st, 10 to the 2nd, 10 to the 3rd, and so on as you move to the left, and then 10 to the negative 1st, 10 to the negative 2nd, 10 to the negative 3rd, and so on as you move to the right. Notice every time you move a space, it goes up by one more factor of 10. Now you'll notice that I put some spaces in here. The metric system starts out by going by 1, but then once they get to 10 to the 3rd or 10 to the negative 3rd, they start skipping by 3s. So if you notice, for example, on the left side, after kilo, or 10 to the 3rd, the next one would be mega. Mega would actually be 10 to the 6th. In the same way, after milli comes micro, and micro would be 10 to the negative 6th. And on it goes. Nano would be 10 to the negative 9th, pico would be 10 to the negative 12th, giga would be 10 to the 9th, and tera would be 10 to the negative 12th. Or excuse me, 10 to the 12th. Like I said, we're not going to be dealing over here too much. We're primarily going to be focused more over here. Now, how do you use this Mean King Henry anyway? Well, let's take a look at some examples. That way we can actually see it practiced. So let's take a look at the first one. 5.92 kilometers, I want to convert that into meters. So if you notice, the same thing between both of those units is the letter M. That means M is the actual unit. So I'm looking at a length here. Now, in the first number, you can see that it has a prefix of K. In the second one, there is no prefix, so that tells me that I'm actually going to be going to the unit itself. So if I go back to my Mean King Henry, I'm actually going to be starting here at kilo and trying to get to the unit. So to get from kilo to unit, I go 1, 2, 3 spaces, and I go 3 spaces to the right. In the same way, that's going to be what I do to my decimal. So I'm starting off with 5.92, and I'm going to move my decimal 1, 2, 3 places to the right as well. Any empty spaces I'll fill in with zeros. So my answer, after converting, would be 5,920 meters. That can also be written in scientific notation, 5.92 times 10 to the 3rd. Let's look at another example. Notice in the second one, the common unit would be the G, and so we're measuring mass here, which is the unit is grams. Now the first number has this funky prefix, remember the Greek symbol nu, which stands for micro. We want to go to the prefix C, which is centi. So if I go back here, I'm starting out in micro, which is right here. Notice that there's multiple m's, so you have to keep them straight. I'm starting out in micro, and I want to go to centi. So I'm going to count over. It's important to count the empty spaces because they are factors of 10. 1, 2, 3, 4. I'm going to move the decimal 4 spaces to the left. All right, so what would that look like? 23.9. Let's move the decimal 1, 2, 3, 4 spaces to the left. Drop the decimal and fill in with zeros. So my answer would be 0.00239 centigrams. That can also be written in scientific notation, 2.39 times 10 to the negative third. All right, finally, let's take a look at an example where you're looking at scientific notation. Notice scientific notation already has the factor of 10 as part of the number. That actually will make our lives a little easier, as you'll see in this example. We're going from hectoliters to milliliters because L is the common unit. So starting in hecto and going to milli, let's take a look at my Mean King Henry. Hecto is right here, and milli is right here. And so I'm going to go 1, 2, 3, 4, 5. 5 places. Remember, every place that I move is a factor of 10. So another way of looking at this problem is that this number is going to be changing by a factor of 10 to the 5th. 10 to the 5th. But will this number be getting larger or will it be getting smaller? Well, think about it this way. Whatever happens to the units, the opposite happens to the number. So what I mean by that is this. Are you going from a big unit to a small unit? Or are you going from a small unit to a big unit? Notice as we go from hectoliters to milliliters, we're going to a smaller unit. If the unit is getting smaller, the number must be getting larger. And so what I'm going to do is I'm going to write 3.7 times 10, but instead of it being times 10 to the third, I'm now going to add the factor of 5 to the 3. That's properties of scientific notation if you haven't gone to that section yet. So the answer would then be 10 to the 8th.